All right, for the next page, we are going to look at, first starting here, these tile questions. This takes us back to the middle of chapter 7, and this was how the book really wanted you to start visualizing the distributive property. So we've got these algebra tiles, which we should be familiar with. 4 of them here are labeled as variable tiles, and in this case x, which means they can be any value. So this could count as 3 tiles, it could count as 100 tiles, it could count as -6 tiles, it could be any value of tiles right here. We don't know what they are, it's variable, it means it can change. But we can account for how many variables we have in this case. And we can also account for how many actual numbers we're given. These single tiles are like actual countable, manipulable numbers. So they're here for us to add or subtract or divide or whatever we want. These we can't do much with other than just count them, say how many there are. So in this case, there's 2 ways of looking at this. One expression is going to use parentheses and one is without. The first one we'll do is the one without. It's the simplest to see, and that's where you just look at it and you count how many x's, right, your variable tiles, plus how many single tiles. So that's going to be an expression built off of 2 terms. You're going to have some number of x's plus some actual number, right? So you would count your x's, and so in this case we've got 1, 2, 3, 4 x's. So you want to make that 4x, and then plus however many tiles you had. You would count the tiles, you could count the rows and count the columns and then multiply to figure it out, or just count them all. It'll be 4x plus some number, how many tiles right there. The other way to think about it is you've got basically 4 identical groups here. You've got this top row, which is a variable plus a certain amount of numbers. And then you see the exact same thing here, the exact same thing here, and the exact same thing here. So if you're repeating the same thing, you can essentially just do one of them and then multiply it however many times it shows up. So you would want to come up with an expression that describes one of these groups, and then you just multiply that expression by how many there are. So this would be, in this case, the other way to answer it is the number of x's in one row plus number of singles in one row, and then you multiply that all times number of rows. So you'd be multiplying that right there. Not really very clearly written, I apologize, but hopefully that makes sense. You're going to have some number here, however many rows, which is 4, and then it's going to be times the number of x's and the number plus the number of singles. It's going to be in that format like that. And then the question finishes with, are they equal? And I think reasonably you should be able to assume yes, they are equal, because they're both describing the exact same thing right here. This is a certain number of variables plus a certain number of ones. So yes, they are going to be equal because they're based off of the same visual. Number 7 is very wordy, and I think just the amount of words confused you. A lot of people underlined each question. There's really 4 questions. What's the area Max's shape? How do you know? And if Zelda has a perimeter of 3 units, does Max's shape have 18 units? And explain. So you've got your explanation will be a point, whether or not the perimeter is 18 units is a point, what the area is a point, and how do you know? And most people lost points because they left out at least one of these 4 things. So let's go through each one together. First off, Zelda's shape is a hexagon. So I'll draw a crude little hexagon here. I believe it is. Let me double check that. Yes, it is, but I did not draw a hexagon. Let me try that again. Zelda's shape is a hexagon and has an area of 6. And I'm actually going to just draw here on the test. So it has an area of 6 right here. And so most of you were able to figure out that Max's area is going to be 6 plus 6 plus 6 plus 6 plus 6 plus 6, or 6 times however many hexagons there are. And that's all you needed to do. And a lot of you wrote an expression or an equation of how you got that, and that was enough. So that's the area. It's just going to be the sum of all these, or you can multiply 6 by how many there are, and that'll give you the answer. Make sure that that's in units squared. Now the perimeter, on the other hand, is a different story. So they give us that Zelda's perimeter is 3. So this space all the way around, if I were to walk this distance, it would be 3 units. Okay? The question is, does Max's shape have 18 units? Well, because there are 6 shapes, one might think, yeah, so if I have 3 here, and I have 6 of these, it would be 3 times 6, which would be 18. But in fact, that's not true, because look at what happens inside of Max's shape. This is a portion of Zelda's perimeter here that is not included in the perimeter of Max's shape. So here's Zelda's perimeter, right here. But inside of Max's shape, part of this perimeter is hidden and is not counted as the perimeter. So whereas here her perimeter is 3, this version of her shape, her perimeter is missing a bit of it. And that's going to be the case for all of Zelda's shapes. A little bit is missing each time. So each time you put 2 shapes together, you're losing some of that perimeter. Now, if you were to pull them all apart and count the total perimeters of all 6 shapes, yes, it would be 18 units. But because you've got some of these shapes bunched in on each other like this, the perimeter is not counted when they're inside like this. So the perimeter of Max's shape, let me do that in green here, is just this right here. And so this is going to be less than 18. Some of you actually figured out that it was 9, and I think you can reasonably say that. But that wasn't asking that. All I was asking is, how do you know that it is or isn't? And so it is not 18 units. And how you know is because some of Zelda's perimeter is cut off every time you place 2 shapes together. And I'm going to go ahead and do number 8 over here as well. Let me just make sure that you understand how to set it up. First of all, which is the dividend and which is the divisor here? I should have said, by the way, show your work, or no calculator. But I did not take off since I did not write that. So for those of you who did this on your calculator, you got lucky. But make sure that you know how to do this, because this will show up on your PARCC test without a calculator. So first off, which is the dividend and which is the divisor? Well, this first guy is your dividend, and this second guy is your divisor. The suffix "sor," like tractor, or I'm trying to think of other words. It basically just describes somebody or something that does something. So a tractor makes tracks. A divisor divides. So the divisor is the thing that's doing the dividing. It's the second factor. So that's going to be 32.5 divided by, sorry about that, 33.8. And when you do these long divisions, the most important thing is to move your arrow over, or move your decimal point over in the divisor. You move your decimal over in the divisor until it becomes an integer, a whole number. There's no decimal point. Once you get rid of that, then you also move your dividend, the one being divided, you move that over the exact same amount. So since I moved over this one, I move this over 1 as well. So that's going to become 325 divided by 338. And then it's just a fairly simple long division problem. I would definitely review how to do that. Look at like Math is Fun or Khan Academy or something. There's hundreds of explanations out there of how to do long division. Make sure you're comfortable with that.